Okay, in number 16, it's in section 8283, it says write a rational function whose graph has a vertical asymptote at x equals -3. So this is the vertical asymptote is x equals -3. Okay, and a horizontal asymptote y equals 0. So let's think about it here. So we're going to have to write a function. We're going to have some kind of function that has a numerator function and a denominator function. And we need to think about a couple things. First of all, if you have a vertical asymptote of x equals -3, that means when you write this as a factor, it would be x plus 3. So that and vertical asymptotes come from the denominator down here. So I know that the denominator, has to have an x plus 3 in it in order to have a vertical asymptote. The second part to consider is, when do you have a horizontal asymptote y equals 0, or in other words the x-axis? Well, that's when the degree of the denominator is greater than the degree of the numerator. Okay? Well, if I just leave the function as it is like this, my degree is 1 for my denominator. So what's my numerator's degree? It's going to have to be 0 or some smaller number, but I'm not going to do a smaller number. So that means I need a constant of some kind. So I'm going to write 1 here. That would be the easiest constant. Or you could put 2, you could put 10. Just put a constant there. Now there's other things you could have done. You want to call it x plus 3 all squared, then put some other thing like x on top. But definitely you need to follow this rule right here. That's number 16. So let's do number 17. Okay, let's do 17. It says, write a rational function whose graph has a vertical asymptote of x equals -3. So I'm back to the same exact thing. X equals -3, which we already said means that it's got to be x plus 3 on the bottom. Okay, and we have to have a horizontal asymptote, y equals 1. Now here, in order to get a horizontal asymptote that's not y equals 0, we want the degree of the denominator equal to the degree of the numerator. Okay, so it's gonna look like this. F of x equals, now on the bottom I'm just going to put x plus 3, but you'll remember that the degree here is 1. Okay, so I need something with a 1 on top. Well, the easiest thing for me to do would have put an x here. Now remember, then you have to use, it's the leading coefficients as a fraction. So that's the rest of the rule. Okay, well, there's a 1 here, and if you do this, there's a 1 here. Those are your leading coefficients. What's 1 divided by 1? That's 1. Y equals 1, which is what we're trying to do. So the simplest one would have been to just write x over x plus 3. Now if you want to put an x plus 1 or plus 3 or some other, don't put a plus 3, because then you'll have a pod and it will be a little different thing. So anything but an x plus 3, any constant but 3, don't put 3 there. That's the only thing, then that would be fine. Okay, number 18, it says write a rational function whose graph has a vertical asymptote of x equals, vertical asymptote of x equals -3, which would mean x plus 3. We've already talked about that. And it says a slant asymptote. Well, a slant asymptote only happens, well, we want it to be this x minus 1. And that only happens when the degree is plus 1 equals, of the denominator equals the numerator. In other words, the numerator is 1 bigger. The numerator is 1 bigger than the denominator when you do synthetic division. So one way to do this problem is to set it up so that we're going to do synthetic division with this here. So what we're doing here right now is we have f of x. We know the bottom is going to be x plus 3. So that's why I'm going to do synthetic division with -3. And the top, and we don't care about the remainder, but we need to set it up so that we get a 1 here for this leading coefficient, and we also get a -1 for the constant. So we want -1 there. So what number should go there? Well, in order for this to be a 1, it must be a 1 here. Okay? In order for, so then you get, so when we add downwards, we get a 1. Then we're going to get -3 times 1 is -3 here. What number could you put here? Okay? So remember, we want to end up right here. What number would go right here so that what number would go there? So that when you added downwards, this would become -1. So in other words, question mark minus 3 has to equal -1. Well, doesn't that make sense that if this is a 2? So I'm going to put a 2 here. Now it turns out that you'll get a 3 here when you do the multiplication here. You'll get a 3. Okay, but I don't really care what happens here. I don't care what happens here. So you can put whatever number you want. I'm going to look at this here, and remember, this is the top that I want. How do I read that? Well, if this is x, then this is x squared, and this is x. So I need x squared plus x on top. Now you're welcome to put any other number here that you like. And that's the only thing, sorry, that's supposed to be a 2x there. Okay, it's supposed to be a 2x there. Anything you want there, and that will get you the right answer. Another way to do it that's a little faster than trying to do trial and error with the synthetic division is to just write what your asymptote is supposed to be. Remember, your asymptote is supposed to be x minus 1, and then you're supposed to have some kind of remainder that has a lower power than there, so some constant over x plus 3. Because remember, for asymptotic behavior, this becomes 0. So I don't even care if you put a 2 here or something like that, or any other constant there, but it's got to be lower than x. So it's got to be a constant of some kind. So you could put a 1 there. Is the easiest one to do. And this also works. When you do all the work there, you're going to get, when you do all the work there, I think you get 3 here, but it doesn't really matter. So I did it with synthetic division. You could have done it this way as well.